Okay, I just want to show you some examples of simplifying fractions and ratio, because they're quite similar. What you have to remember is whatever you do to the top of the fraction, you do to the bottom. Whatever you do to one side of the ratio, you do to the other side. And it's usually about either multiplying or dividing. Usually with simplifying, we're trying to make the digits the smallest they can be, so we're usually dividing. Okay, so you've got 18 24ths here, and they want us to simplify it. So the best advice I can give you, you are level 5 so it shouldn't be a problem, is you need to know your times tables backwards. If you know your times tables, then you should instantly see a number that you can divide these by. So to simplify, we must divide the top and the bottom by the same number. So think of your times tables. If you struggle with your times tables, the easiest thing to do is just look to see if they are even, so you could divide by 2, because you can do it in lots of stages. Okay, so you could divide these by 2. Let me show you. Divide by 2, I do these little smileys and frowns. 18 divided by 2 is 9, 24 divided by 2 is 12. Okay, but I think we could probably get smaller than that. So to help with the first stage, if you now look at 9 and 12, you should be able to go, aha, there's a times table here that I know. I know that 3 goes into 9 and so does 12. So we should be able to divide by 3 this time. 9 divided by 3 is 3, 12 divided by 3 is 4. And can you think of a number that goes into 3 and 4 apart from 1? 1 is a bit pointless because it just gives us 3/4 again. I can't, that's the simplest form. So that's one way of doing that one. If you knew a different times table, you could probably do it in smaller steps. So I know that 18 and 24 are in the 6 times table. So 18 divided by 6 is 3. And 24 divided by 6 is 4. So that does it in one step. It really doesn't matter if it takes you more than one step, as long as you keep going until you can't get those digits any smaller, then you've simplified it. So it really depends on what you know with your times tables and what you spot on the day. So this an example of simplifying fractions. It's the same as finding equivalents, except in equivalents we often multiply, whereas this time we're dividing. If we now look at ratio, ratio works in the same way. Whatever you do to one side, you have to do to the other. So our ratio is 40 to 60, and we have to simplify it to the simplest thing it can ever be. Well, I can see straight away, you should notice these numbers have got a 0 on it, which tells me straight away that I can divide by 10, which I'm sure you spotted. So if I divide 40 by 10, I get 4. And I have to do the same over here. Divide 60 by 10, I get 6. Now I've got 4 to 6. Alright? Remember, I'm trying to make these digits the smallest the digits can be, so I think I can divide by something else, because they're both even. So I think I can now divide by 2. So 4 divided by 2 is 2. 6 divided by 2, that is 3. 2 to 3. Look at your ratio. Is there a number that goes into 2 and 3 apart from 1? Because again, 1 would just leave it as 2 and 3. There isn't, so that's your simplified ratio. You might have been very clever when you looked at this and thought, well, I can see it's 2 and 3 already. You might have divided by a different number, but it doesn't matter if you do it in stages, I suppose, as long as you make sure you go right down to the smallest digits you can get. And that is simplifying, so it's the same for ratio, really, and fractions.